Oh wait, right Q has stuff on it.
Don't get killed. Okay, let's, my son keeps saying, let's grind this out. Keep grinding. So 3 more examples here. And again, we're going to do x squared. Hang on. I think I put the minus in the wrong place. That one. So on x squared, y squared over 4, z squared over 9. Oh, yes, sorry. So it's going to be plus, plus, minus, and now 0, not equal to 1. So what does that one look like? Well, let's try them here. If, let's see, try this one. If z is 0, then I'll get x squared plus y squared over 4 equals 0. And we've seen that one before. That's the only way that can happen is if both x and y are 0. So the only thing that we get there is just a single point. Slice it, we just get a single point. What about if x is 0? Then we get y squared over 4 minus z squared over 9 is 0. Not equal to 1 this time, it's actually equal to 0. So that one's, well, let's see. Bring this to the other side. Y squared over 4 equals z squared over 9. And then just take square roots of both sides. I'll get y over 4 equals plus or minus z over 3. Which, those are just lines. One of them is slanted one direction, the other is slanted the other direction, like that. So I actually get crossing lines from this. And they're going to cross at the origin. So I hit a point, I got a crossing lines. If I tried y equals 0, it turns out I get something very similar. X squared minus z squared over 9 equals 0. The y term drops out. And so when I bring the z part to the other side and take a square root, I'll get x is plus or minus z over 3, which is also crossing lines. I'll try and put all these things into the picture. It's a little tricky, so I'm going to draw one more here. If z is 3, and in fact, plus or minus 3, it doesn't matter because it's going to get squared out. So if I go 3 units up or 3 units down, I end up getting the same thing. X squared plus y squared over 4. And then when I plug in 3, this will be 9 over 9, which is 1, but it's minus. So I'm just going to add it to the other side. So I'll get minus 1 over here, but I want to put it on the other side as plus 1. So now, and I've already seen this one, that is an ellipse. So if we have like 5 level curves here, or 5 slices that I think we can sort of put together. And I do think I want z up. So if z is at the top, x is out, y is out. So I get the origin, and that's the only thing I get at level 0. If I'm up at level 3, I get an ellipse, which is 1 on the x-axis and 2 on the y-axis. It's sort of that. And down below here at minus 3. And then I think the second one isn't too bad. These are crossing lines that come in and hit that ellipse. And this one comes up and hits that ellipse. And honestly, that's basically enough to see what's going on. If I tried to draw these other crossing lines, they come out of the board and they go into the board. So really what we've created is we've created this shape. And again, it's infinite in both directions. So this here is our double cone. And if we want to be precise, we can call it a double elliptical cone. And that's the equation of that surface. It's the outside of two cones stacked one on top of each other. Just by changing the plus and the minus, we end up getting crazy different things. We change this to a 0 instead of a 1, and it's super sensitive to these small changes. Okay, two more here. This one's pretty easy. So z is, now I don't even have a square on the z. So I've got x squared over 4, y squared over 9 equals z. So I don't have z squared anymore. So let's look at, we're probably going to need at least 3 levels here. This one's maybe the easiest one. If y is 0, if we drop this last term here, we just get z equals x squared over 4. So if I was to slice it in the xz plane, I get this. And now we get our final conic section. That's a parabola. So we get a parabolic cross section on that one. If x is 0, I get z is y squared over 9, which is also a parabola. Just turn sideways, it's a little bit stretched open a little bit more. If I tried z equals 0, then I get 0 equals x squared over 4 plus y squared over 9. And again, squaring things and adding them together to give 0, the only way that happens is if they're both 0. So that's just going to give me a single point. So again, in the plane, the only thing I'm going to see is that single point. One more, and I think we can piece it together. If z is 1, then I'll get 1 equals x squared over 4 plus y squared over 9. And we've seen that one before, or at least something very similar to it. That is an ellipse. We have two parabolas. Ellipse, it hits at one single point. If z was negative, we would get nothing because there's no way to get two positives together to get a negative. So nothing is at levels negative levels. So everything is going to be above, or wherever you put the z-axis. So put the z up here. So if x is 0, I get this parabola z equals y squared over 9. This is a parabola in that direction. If I cut it with the xz plane, I get a parabola coming out of the board and into the board. You can see that I have the point at the origin, so that's the third one. And the fourth one is an ellipse. So if I go 1 unit up, I'll get an ellipse. And honestly, the more points I go up, I'll get another ellipse. Let's go through that. So what have I created here is I've created a new ellipse. Like that. It goes up infinitely. So it looks like you took a parabola. Well, it's not quite a spun parabola because the cross sections of it are ellipses. So I get an elliptical paraboloid. Most of the stuff looks like parabolas. These two cross sections look like parabolas, and the cross sections, flat ones, look like ellipses. So it's kind of like a regular bowl. You just spin a parabola and then stretch it out in one direction. Again, it takes a little bit of creativity to see this stuff, especially this last one. This is always the tricky one to put everything together. So z is, sorry, y squared over 9 minus x squared over 4. Again, one little change right there. Okay. So how do we do the levels on this one? Well, let's see. If x is 0, sometimes I'm doing these out of order, but if that one drops out on the end, I get z equals y squared over 9. And that's a parabola. So that's one we've already had. It opens up. If I tried y equals 0, I'll get z equals negative x squared over 4. And that's also a parabola, except now it's facing down because I've got a minus in front of it. The first one's facing up, second one is facing down. It turns out if I do z equals 0, I don't really get anything interesting. If I try two more here, if I try z equals 1, then I'll get 1 equals y squared over 9 minus x squared over 4, which is a hyperbola. And if I try z equals minus 1, I go down 1 unit, it's minus 1 equals y squared over 9 minus x squared over 4. And if I just multiply everything by negative 1, this will be 1 equals x squared over 4. I just change all the signs, minus y squared over 9, which is a hyperbola, but it now is opening the opposite direction as the one that it did before. So I've got two parabolas in those cross sections, and I've got two hyperbolas in those cross sections. And this one, draw it, is interesting. And again, I want z to be at the top. Here's x, here's y. So here we go. So in the x equals 0 or yz plane, I've got this parabola. So that's a parabola that is opening up. In the y equals 0 plane, I got a parabola, but it is now opening down. And that's coming into the board and going into the board and coming out of the board, actually. So you kind of put one U, like a U and then another U, but turned 90 degrees. And z equals 1, I'll get a hyperbola that starts on these 2 points and opens this direction and this direction. And then if I go down 1 unit, I start on this parabola, and I will have a hyperbola this way, and I'll have a hyperbola back the other direction. A little bit hard to see. But if I drop a sort of dotted line down here, I drop a dotted line down here, and I drop a dotted line, or this will actually be, I guess, maybe a dotted line down here. What we end up getting is something that looks like this. And maybe back here. Now it's a little hard to draw this last part. And down. And I don't know if any of you guys ride horses or not. That's probably a super terrible. Maybe it's like an old English saddle, but it looks like a saddle. And we should sit here, I guess. And I ran out of room for everything here, but this, if I guess, no, not there. Stick it in here. Yeah. So this is called a hyperbolic. Again, the parabolas, there's two parabolas, so it gets the name of paraboloid. But because the other cross sections are hyperbolas, it's called a hyperbolic paraboloid. And that really tests your drawing skills here. But you'll notice that all these graphs that I did just had an x squared, a y squared, a z, or a z squared. And you can create these crazy things by just changing the sign and changing the order, putting a 1 in or a 0 in different places. And so I think for the homework, it's a lot of practicing distances, practicing drawing these things. And so hopefully you guys are creative drawers. Anyway, I think that's what I got for this afternoon. We still probably have about 20 minutes if someone has any homework questions, but as usual, if you guys are good, and you can go work on that or go take a nap or something. So happy to answer questions.
Sir, what is the best way to start studying for the test?
Homework. Yeah, there won't be any curveballs. Again, it's open book, open note. So, maybe read back through the notes we did. I put them all on Canvas. I'll try to correct the homework as much as possible. I probably won't take on points, but I'll try to give tips on that. I'm going to try and make the problems pretty similar to the ones you've had. And so maybe redo those and do a couple that are around those types of problems. That's about it. Pray. Sorry, no prayer in school. But as long as there's math classes, there will be prayer in school.
Okay, thank you, sir.
Okay. Really helpful there, yeah. So yeah.
Just wondering.
Go ahead.
Go ahead. You're good.
I was just gonna say, any questions?
Yeah, so I was just wondering if you could run through number 12 maybe from 9.5.
Well, okay. So what you want to know is where there's horizontal and vertical and the angle values are 0 to pi. So you could draw the picture. It's often not a bad idea to go ahead and draw the picture. This one looks like it's 2 units up and it's a circle. I'm going to redo that for sure. Okay, so if you draw that graph, you get this. So I think it's pretty clear that this here is going to be horizontal. That's horizontal, and then the two side ones are vertical. But in order to see this analytically, you want to find the slope. And so the slope formula, which I don't know, I keep forgetting the order of it myself, but right. So I need to put sine and cosine, and this is plus and then minus sine. And that's part of the formula. And then what gets put in here are the derivative of your function. So the derivative is 2 cosine. This is 2 cosine. And then the other part is just the function itself. 2 sine, 2 sine. So if I wanted to clean that up a little bit, I guess the top, this is 2 cosine sine, this is 2 cosine sine. So that's going to be 4 cosine sine. And then the bottom is 2 cosine squared minus 2 sine squared. So I guess we could divide everything by 2. Might as well do that. So it's 2 cosine sine on the top, and the bottom is cosine squared minus sine squared. So the horizontal tangents are when the slope is 0. So I want to set my fraction to be 0. And a fraction will be 0 whenever the top is 0. And I got to make sure at the same time the bottom's not 0 at the same time. So 2 cosine sine, set that to 0. Well, that'll occur at whenever the cosine is 0 or whenever the sine is equal to 0. And so when the sine is 0 at 0 and pi, the cosine is 0 at pi over 2 and 3 pi over 2, but that's out of my range. I only want the range from 0 to pi. So that's, yeah, sine is 0 at 0 and pi, cosine is 0 at pi over 2, and therefore at those points specifically, the radius will be, well, I put all those points back up in here. So 0 goes in, I get 2 sine 0, and that's 0. So I have the point 0, 0, which is the origin, which makes sense. So if I look at the picture, it's flat there. Pi is exactly the same thing. Both of those represent the origin because I haven't moved at all. This one, if I plug in pi over 2 to get r, I'll get the sine of pi over 2, which is 1, and then double it. So that would be at 2. So I would rotate 90 degrees and go out, and that would be the top. So horizontal tangent, slope 0 at the top, and at the bottom, just kind of like I expected. And then for the vertical tangent, that is when the slope, well, when it's straight up and down, which means that the slope can't, it has to be undefined, basically. So how do you make a fraction undefined? Well, you make the bottom equal to 0. So vertical tangent, if the slope is infinite or undefined, however you want to interpret that. And that'll occur when the bottom is 0, cosine minus sine is 0. So you could, what could you do there? I mean, maybe an easy one is just, you could bring the cosine over, or bring the sine over, divide over by cosine squared, and you'll get 1 equals tangent. And so we're running out of room, but that means that the tangent is plus or minus 1, take square root of both sides. And that occurs at 45 degrees and 135 degrees. So pi over 4 and 3 pi over 4. Sorry, I ran out of room there, but if I go 45 degrees and go out to the curve, I'll hit that point right there, which kind of makes sense because I have a vertical tangent at that point. So that's when theta is pi over 4, and I might as well just put it here. Therefore, r is, well, I have to go back to r, and I plug in pi over 4. Sine of pi over 4, that's the familiar square root 2 over 2, and then I double it. So it's 2 square roots of 2 over 2, and I can cancel the 2's to just get square root 2 like that. Same thing at 3 pi over 4. I go 1 pi over 4, 2 pi over 4, 3 pi over 4, and I'll hit that one there, which makes sense because the line is vertical there. So theta is 3 pi over 4. And similarly, I plug it in, and the sine will be square root 2 over 2, which I double to get this regular square root 2. So those 2 points are the vertical tangents, and then these other points are the horizontal.
Thank you, sir.
Anyone else?
Okay, thank you.
Yep.
Thank you, sir.
Yeah.
Nerds.